In this video, I'm going to explain what we're going to do in this lab, and also I will show you how to set up everything to collect data. Now you see the motion sensor is already connected to this universal interface. In order to control that, we need to open Pasco Capstan data collecting system. The first thing we're going to do is set up the motion sensor. To do that, go to the hardware setup, click on that, then you will see this virtual 850 universal interface. Click on the digital input 1, right click, then you need to select motion sensor from this drop down menu. So I'm going to type motion so I can see the motion sensor. Now it is connected. Click one more time on the hardware setup to close this window. Go to the sample rate and change it to 40. I'm going to measure the position and velocity of this card. So I need 2 graphs. Go to this menu in the right hand side of the window and drag and drop 1, 2 graphs. I need to select the axes, position as a function of time, and velocity as a function of time, and hit record and make sure system is working. So I'm going to move my hand back and forth, and now you can see it's recording data. Now let's try to understand what we're going to do in this lab. So we're going to compare the total energy of this system. So system has 2 components, cart and the mass hanger. They are connected using this string, and you can assume mass of the string is negligible compared to the masses of the cart and the hanger. The string is going off this pulley. Pulley is frictionless, and also the mass of the pulley is very small compared to the mass of the cart and mass of the mass hanger. So we can assume this is the system has only 2 components, which are cart and the mass hanger. Total mechanical energy of the system has 2 components, kinetic energy and the potential energy. If we know the velocity of the system, we can calculate the kinetic energy. Components of this system, they are moving with the same velocity because they are connected. And if you know the velocity of each component, you can calculate the kinetic energy of the system. In order to calculate the potential energy, we need to declare a reference level. So I'm going to take the flow of this lab as my 0 potential energy level. Then I can measure the height to each mass from the lab flow to calculate the potential energy. Potential energy equals mass times height times acceleration due to gravity. And then I'm going to move this cart backward. Now I'm going to set the initial height of the mass hanger to a certain value. Then I'm going to measure that height from the flow to the initial position of the mass hanger, and also I need to measure the height from the floor to the initial position of the cart. Then I can calculate the potential energy of the system before it start to move, and once I release the cart, the system will move downward because of the weight acting on the mass hanger. Using the motion sensor, I'm going to get the final velocity of the system when the mass hanger hit the ground. Then I can calculate the final kinetic energy of the system. During this activity, the height from the floor to the cart will not change, so the potential energy of the cart is constant throughout this activity. Now I have all the data I need to compare the initial total energy of the system and the final total energy of the system.